In this video, we're going to show you how to install the S&S HI-4N ignition. I'll be installing the HI-4N on this 1990 FX STC. To save time in this video, I've already removed the stock ignition coil so we can concentrate on installation and adjustment. I've also removed the seat to disconnect the battery and one of the gas tanks to provide access to some of the wiring. If you have to remove the gas tank, be very careful. If you spill some fuel, clean it up and make sure you have adequate ventilation. It's also a good idea not to smoke. I've left the stock rotor cup installed because we'll be reusing it. For older bikes that have a point ignition system, you'll have to install one of these rotor cups, which are also available from S&S. We'll also save the stock standoff screws. Although the HI-4N can run in dual fire mode, and we could reuse the stock 3 ohm dual fire ignition coil, we're going to replace it with an S&S 3 ohm single fire coil in order to upgrade to single fire operation and to ensure the best performance. The HI-4N is available in a kit with a module, an S&S single fire coil, and a set of premium spark plug wires. It's an easy way to ensure that you have everything you need to upgrade your ignition system. When you think about it, if you're going to shell out your hard-earned dough for a performance ignition module, don't you want to take advantage of everything it has to offer? It's worth a few bucks to get the coil and wires that'll let you take advantage of all the features. The S&S high output single fire coil actually contains 2 separate coils in one package, one coil for each cylinder. Some installations on older bikes may require a tach adapter to correct the readings of tachometers designed for dual fire ignition and to adapt earlier tachs that were designed for a high voltage signal from a point ignition system. These are available from a number of aftermarket suppliers. We won't need this adapter because this bike, for one thing, was originally equipped with electronic ignition, and for another, it doesn't have a tach. We have all the parts we need, so let's do this. You notice that I've disconnected the battery ground cable. This is a safety precaution we take whenever we work on the electrical system. The easiest way to install the module is to push the cable through the wiring channel and tuck the cable into the notch in the module and insert it into the cam cover. If you note the position of the stock module and put the HI-4N in about the same position, it should be timed close enough to at least start and run. But it really isn't critical. It's easy enough to static time the ignition in any case, as we'll see. Install the stock standoff screws. If there are washers, they may be needed to make sure the standoff is the correct height for the timing cover. No need to tighten the standoffs yet because we still need to time the module. Before we do the timing, we'll have to route the wiring harness to the coil and do the wiring hookup. As much as possible, route the harness along the frame rails. Avoid areas where it might get frayed by contact with moving parts or toasted by the exhaust pipes. Use tie wraps to make sure it stays securely in place. We've got the wiring harness up to the location where the coil will be. So now let's install the new single fire coil. It bolts right into the stock coil bracket. As you can see, the wiring harness is way longer than we need, so we'll have to trim it. But let's think about it first. As they say, measure twice, cut once. We need to cut the wiring harness to an appropriate length for the installation. Leave yourself a little slack, but you don't want loops of extra cable getting in the way. Keep in mind that we need to connect a wire to the VOS, which is right here. So we need to leave the violet wire long enough to reach it. So let's cut the protecting cover of the HI-4N wiring harness here at the length required to reach the coil. But let's route the violet and brown wires along the frame and cut them long enough to reach the VOS. The brown wire is for the tachometer, and although this bike doesn't have one, let's leave that option open. The kit includes wiring terminals which need to be crimped on with a crimping tool. A compound action ratcheting crimper is highly recommended. The ring terminals are used on the coil connections, which includes the white, pink, and blue wires. The inline spade terminals are used for the tachometer and VOS connections, which are brown and violet wires. The instruction sheet that comes with the HI-4N has some very clear diagrams that show how to connect the wires for a number of applications. This white wire from the stock wiring harness is the plus 12 volt switched power supply. So connect it to the positive terminal on the coil along with the white wire from the HI-4N. The pink wire goes to the terminal of the side of the coil you want to use for the front cylinder, and the blue wire goes to the rear cylinder terminal. It really doesn't matter which terminal is used as long as the corresponding plug wire goes to the correct cylinder. Connect the violet wire to either wire of the VOS unit and zip tie it in place. The other wire on the VOS is already connected to ground. VOS is an acronym for Vacuum Operated Electrical Switch. When your engine is under a load and you have the throttle cranked open, manifold vacuum drops, which causes the VOS to open, which in turn signals the HI-4N module to reduce the ignition advance to prevent your engine from knocking. This bike came off the factory floor with a VOS unit, which we will reuse. An S&S Super E carburetor has been installed on this bike, and someone has done a very tidy job of connecting the VOS to the manifold. You want to keep the hose as short as possible, and you can't get much shorter than that. If you're installing an HI-4N on an older bike that does not have a VOS, we highly recommend that you install one. In that case, your manifold or carb won't have this vacuum hose nipple to hook it up to. But not to worry, you can easily install a nipple, or you can replace the manifold with one that's equipped with a VOS nipple. Both are available from S&S Cycle. The brown wire of the HI-4N connects to the tachometer wire of the bike's wiring harness. This bike doesn't have a tach, so I could just tape the wire up, but I've put the insulated spade terminal on the brown wire, and I'll just leave it. If in the future we want to install a tach, the wire is there and ready to go. Once all the wires have been connected, use zip ties to secure them and keep them away from the hot engine parts or anything that could abrade them. Reconnect the ground cable to the battery and we're ready to set up the module. Since this is a stock engine with electric start and we're running a single fire coil, we'll select mode number 1, which is a single fire, single spark OE curve electric start. If you want multiple sparks, you can switch to the multi-spark mode number 3 after we've done the ignition timing. That's because most timing lights won't work with the multi-spark mode. If you have a kickstart bike, it narrows our options, and we choose mode number 8, which is single fire, single spark, OE curve, kickstart. There are no multi-spark kickstart modes. In either of the kickstart modes, the ignition fires on the first engine revolution, while in the electric start mode, the engine is allowed to turn over a couple of revolutions before the ignition fires to save the starter. We've initially set the advance rate switch to number 9, which is the fastest advanced curve. That should be fine with a stock engine. If we have problems with knock, we can set it to one of the lower numbers for a less aggressive advance curve. We'll set the rev limiter to 5,500 RPM. The owner of this bike isn't a hot rodder, so he'll probably never rev it that high. Now we're ready to set the ignition timing. For the initial static timing, we need to turn the engine over until the front cylinder is at top dead center on the compression stroke. So we'll pull the spark plugs and make it easier to turn the engine. Place a jack under the frame and raise the rear tire off the lift so we can use it to turn the engine. Remove the timing hole plug. Shift the transmission into high gear. You can do this yourself, but a helper really makes it easier. We'll use the rear wheel to turn the engine until the front cylinder is at TDC on the compression stroke. If you hold your finger over the spark plug hole of the front head, you'll be able to tell when the piston is coming up on compression. You may even be able to make some rude noises while you're at it. Okay. Once you know the piston is coming up on compression, slowly turn the engine until the front cylinder TDC mark is in the center of the timing hole. This bike has stock flywheels, so the TDC timing mark is a vertical line. If your bike is older or has S&S flywheels, the timing marks will be different, but that's all covered in the instruction sheet. Keep in mind that the TDC timing mark also comes up on the exhaust stroke. So it's really important to know that the piston is on TDC on the compression stroke. Turn on the ignition switch and make sure the kill switch is in the run position. Loosen the standoffs and turn the ignition module until the LED on the top of the unit just goes out, and snug the standoffs. The ignition is now roughly timed. It's close enough for the engine to start and run, and that's all we need at this point, because I'm going to confirm timing and make the final adjustments with a timing light. If you've ever used a timing light on a Harley-Davidson engine before, you know that it can be a bit of a challenge. Even with one of the clear plastic plugs, shooting the timing light into that timing hole and seeing the marks can be difficult. It's doable, but let me show you an easier way. We've just set the engine to TDC front cylinder on compression, and the front cylinder TDC mark is in the timing hole. This is the mark you'll see if you're using a dial back or adjustable timing light. If you're using a standard timing light, you'll need to use the advanced timing mark on the flywheel. Depending on the timing light you're using, you'll need to time to one of these marks, but you actually need to be looking at the flywheel. An easier way is to remove the primary inspection door and put a mark on the alternator rotor, either at TDC or at 35 degrees before top dead center, depending on which style of timing light you're using. I'll just clean the rotor with solvent and mark it. Normally I'd use a felt tip marker, but for the video I'll use some white paint. This is much easier to see, and it's not going to be blowing oil out at you. If you do get some oil coming out, you can temporarily drain the primary. Reinstall the spark plugs and the new plug wires. Make sure to connect each with the correct cylinder in the correct terminal. Shift the transmission into neutral and let the bike down off the jack. If you had to remove the gas tank, replace it now and put some fuel in it so we can run the engine. I'm going to use a dial back timing light, and I'll set it at 35 degrees. Start the engine and run it at about 2,500 RPM. Here's another procedure that you can actually do on your own, but it is so much easier with a helper. Shoot the timing light either in the timing hole or at the alternator rotor, and look for the front cylinder TDC timing mark in the center of the timing hole at 2,500 RPM. We're a couple of degrees advanced, so we'll loosen the standoffs and rotate the module slightly counterclockwise to correct the timing. Tick marks on the outside edge of the module make it really easy. Each tick mark represents 5 degrees, and the large tick marks are 10 degrees apart. Rotating the module clockwise will advance the overall timing, while turning it counterclockwise will retard it. Recheck the timing and it's right on. It's that easy. As I mentioned before, I've set the advanced rate switch to number 9 or maximum advance, since this isn't a high compression engine. If the engine knocks under a heavy load, I can always set it back a click or two, but I doubt we'll have a knock problem since we're using a VOS, which retards timing when the engine's under a load. Put everything back together and we're done. We've installed the S&S HI-4N ignition. We've got it set up, we've got it timed, so we're ready to ride. With this ignition installed, we can look forward to easy starting, smooth idle, improved throttle response, and better fuel mileage. We hope this video has helped you get your ignition on and shown you just how easy the S&S HI-4N really is to install. Thanks for watching. We hope to see you on the road, not by the side of it.